circuit, choose the correct statements. Impedance, power factor, all everything is asking here. So what to do with parallel circuits? If you know complex number, how to apply? Okay, well, very easy. Provided you should work out with complex number. Without complex numbers also, we can find out the things. And that's what our syllabus is. So what we have to do, without any complex numbers, we should try to solve the problem. Okay, try to develop the approach. Let's assume that current, here only I'll show it. We have only half an hour time. I'll try to wind up this one. Let the current here be I2. Let the current be I1. Then applied voltage is 100 sin omega t. This is the maximum voltage. So VRMS will be how much? 100 by root 2. √2, keep it here. So what is I1? I1 we can calculate. I1 should be equal to VRMS by XC 50√2 by 2. What is the phase angle of this? I think what should be the current? Current will, the voltage I'm taking reference. Across capacitor, current should lead the voltage here. So when I'm writing here only, I'll bring that phase angle. Plus 90 I'm bringing. So what is I1? I1 should be equal to VRMS is how much? 50√2 by 2. Okay, then let's come for I2 now. So what is I2? I2 should be the impedance. First we'll calculate the impedance of circuit. Z2 should be equal to R square plus XL square. 1 square plus 1 square root 2. Then what is I2 is equal to VRMS by Z2. VRMS is how much? 50√2. Now what about phase angle? What would be the phase angle? Not minus 90, it's the RL. R and L is there. So what is the phase angle of circuit for RL? So this should be the R. This should be XL. This should be Z2. So R equal to XL. So tan phi 2 1 by 1 pi by 4. So this will be how much equal to minus 45 degrees or 50 minus 45 degrees. Able to make it out? So this impedance triangle is very important. This is for the branch 2. And now you can ask question, why you are writing minus 45? It's not a series circuit. Come for here. Compared VRMS is I'm taking 0 reference, and across the inductor circuit, what will happen to current? Current lags the voltage. No, the voltage is having 0 phase. Justified showing impedance triangle in the 4th quadrant, but earlier in series circuit we used to show this in 1st quadrant because the voltage, this is having a 0 phase. Nearby for your convenient, I'm writing it. So here if you I'll just write it in this way. Or no need of that one. So just you can get on to even this I2 will be, so this will be just, I'm assuming that the phase angle will be pi by 4 and the current across that will lag by 45 degrees. Again, so just a rough diagram I'm putting here. So now everything we have to include one phasor diagram. The original phasor diagram is what we'll go for here. And let's come for that. What is the reference? VRMS is 0 phase. I'll start with this. What about current I1? It is leading. It should be correct. And what about current I2? I2 should lag. I2, what happened? The I2, the I2 what happened should lag by how much of angle? 45 degrees. So the I2 will come in fact here like this. This is not exact. So just only the tan phi relationship I brought it here. This will be 45 degrees. Is it justified? You can draw this in first quadrant or anywhere. Don't show VRMS here. You can see the I2 and VRMS will have some phase angle. The impedance triangle is what I drawn. So now let's calculate so what is asking now? Impedance of circuit. So how to calculate impedance of circuit? We know total applied voltage, VRMS value, and if I can calculate the total current, then I can calculate the impedance. No? Magnitude of current, VRMS by IRMS will be the impedance. Power factor of circuit. How to bring the power factor, that also will check it. Peak value, average power. So first we'll calculate the total current in the circuit here. So total current, how much it will be? Vector sum, we have to take it. So this magnitude is how much? 50 by root 2 and this is 50. Let's calculate the x component, y component. X component of current will be I2 cos 45. This will be 50 by root 2. What about y component? Y component will be I1 minus I2 sine 45. I1 is 50 by root 2 minus 50 by root 2. So resultant how much will get? 0. So the resultant current, how it will flow? It will flow in the direction of the phase of the resultant current. And what is I is equal to? Iy is 0. So therefore the resultant current so what should be the phase angle of this? This is having phase angle of 0 degrees. So therefore the resultant current, how it will be? It will be along VRMS. Then what is the phase angle of circuit will be? Will become 0. So this I is nothing but IRMS. Let's come for one by one all the quantities. So what is the phase angle of circuit? Will be 0. Shall I write like this? Tan phi will be 0. The phase angle of circuit is 0. Therefore, phase angle of total circuit it is. Because the phase angle of the resultant current and VRMS is same. The I and VRMS are having same phase, 0 phase. Let's come for this one. So now we know IRMS, we know VRMS. Can we calculate the impedance? What is the basic formula? Z equal to VRMS by IRMS. VRMS is how much? 50 by root 2. Sorry, 50 root 2. And what is the IRMS value? 50 by root 2. So 2 ohm is what? Impedance. Then power factor of circuit. Anything can you say power factor? Shall I say unity? Because phi is phase angle is 0. What should be cos phi? Cos phi will be equal to 1. So what is the power factor of circuit? Not 1 by root 2. In fact, it is equal to unity. Power factor is equal to cos phi, cos 0 equal to 1. Peak value of current to the resistance. Peak value of current to the resistance. So what is value of I2? We know I2 50. It's a RMS, no? So what is the peak value? I2 is equal to I2m by root 2, no? Average power supplied by the source. Tell me, who will dissipate power? This is something very important. Who will dissipate power? Inductor, capacitor, any circuit, series, parallel, any number of loops, let it be, only resistor will dissipate power. This is something very, very important. We did this analysis only for series. Now in the parallel also, I'm going to say that resistor, what is the role of inductor, capacitor? They'll just bring some phase angle. They'll make current and voltage across them by 90 degrees. They'll introduce a phase angle of 90 degree across them. Between current and voltage, they'll introduce a phase angle of 90 degree. They don't consume power. They don't dissipate power. Either series, parallel, or even complicated circuit also. Only the resistor will dissipate power. So do we know what is the current across the resistor? Or shall we do one thing, total current? Anything directly go for I2 square R? Or that's one, no, the power dissipated, average power supplied by the source is telling. So that I should write V into I. Power dissipated by circuit, I2 square R. I'll continue here. So what is the power dissipated? Average power equal to I2 square into R. This was the power supplied, no? Shall we write I into V? Any problem? Why I'm not writing VRMS into IRMS? Anybody? In AC circuit, what happens? Apparent power, reactive power, and the resistive power will be there. The resistive power is what? Power supplied by the source. Okay, clear, no? The resistive power is what? The power supplied by the source here. So I2 square R should be taken, not VRMS into IRMS. VRMS into IRMS is what? Apparent power. So you should call this one only power supplied by the source. This is something very important again. See, it's like a, that's what we call like this. Power dissipated in the circuit, I2 square R, or power supplied by the source. This is the actual power supplied by the source. What is the apparent power? VRMS into IRMS, which is of no use. I think that they will not ask, but they can ask you something like this. So don't write VRMS into IRMS.